A lock nut on the outside of an enclosure and a metal bushing on the inside of the enclosure do not constitute a listed method for establishing a reliable grounding path as per the National Electrical Code. The NEC mandates specific and approved methods to ensure effective equipment grounding, crucial for safety and proper system operation. Grounding is the process of creating a low impedance path for fault current to return to the source, facilitating the rapid operation of overcurrent protective devices like circuit breakers or fuses. This rapid operation minimizes the duration of potentially dangerous voltage on equipment enclosures and other conductive parts, reducing the risk of electrical shock. Several methods are approved and commonly used for equipment grounding. Firstly, the use of listed grounding bushings and grounding locknuts in combination, when properly installed and torqued, provides a reliable grounding connection. These devices are specifically designed and tested to establish a low impedance path. Secondly, equipment grounding conductors, or ECs, are often run within the conduit system. These conductors, typically copper or aluminum, are connected to the equipment grounding busbar in the electrical panel and then to the equipment enclosure, providing a dedicated grounding path. Thirdly, bonding jumpers can be used to connect metallic enclosures and other metal parts to the grounding system. These jumpers ensure that all metal parts are at the same potential, minimizing the risk of voltage differences and shock hazards. Fourthly, the use of listed grounding type receptacles and cord connectors ensures that the grounding path is maintained through the flexible cord to portable equipment. These devices have a dedicated grounding pin that connects to the equipment grounding conductor. Fifthly, for certain types of equipment, such as motors and transformers, the equipment grounding conductor can be connected directly to the equipment grounding electrode system. This provides a direct path to ground, minimizing impedance and ensuring rapid fault clearing. The NEC specifies the requirements for equipment grounding in Article 250. It is crucial to adhere to these requirements to ensure electrical safety and code compliance. The code details approved methods for grounding different types of equipment and systems, as well as the required size and type of grounding conductors. Improper grounding can have serious consequences, including electrical shock, fire hazards, and equipment damage. It is essential to use listed components and follow the manufacturer's instructions for installation. The integrity of the grounding path must be verified through testing and inspection. Regular inspections should be conducted to ensure that grounding connections are tight and free from corrosion. Grounding electrodes, such as ground rods or ground plates, must be properly installed and maintained to provide a low impedance connection to earth. The resistance of the grounding electrode system should be measured periodically to ensure that it is within acceptable limits. In addition to equipment grounding, the NEC also addresses system grounding. System grounding involves connecting one of the current carrying conductors of the electrical system to ground. This provides a stable reference point for voltage and helps to limit voltage surges. The type of system grounding used depends on the type of electrical system and the specific application. Grounded systems are more common in residential and commercial buildings, while ungrounded systems are sometimes used in industrial applications where continuity of service is critical. The NEC provides detailed requirements for system grounding in Article 250. These requirements cover the types of systems that must be grounded, the methods for grounding, and the size and type of grounding conductors. It is important to understand the difference between equipment grounding and system grounding and to ensure that both are properly implemented. Equipment grounding protects people and equipment from electrical shock, while system grounding provides a stable reference point for voltage and helps to limit voltage surges. Both types of grounding are essential for electrical safety and code compliance. When installing or modifying electrical systems, it is always best to consult with a qualified electrician. A qualified electrician has the knowledge and experience to ensure that the system is properly grounded and meets all applicable code requirements. Attempting to perform electrical work without proper training can be dangerous and may result in serious injury or property damage. The NEC is a comprehensive document that covers all aspects of electrical installations. It is updated every 3 years to reflect changes in technology and industry best practices. It is important to stay up to date on the latest edition of the NEC to ensure that electrical systems are installed and maintained in accordance with current requirements. The NEC is not a substitute for proper training and experience. It is a guide that provides minimum requirements for electrical safety. A qualified electrician has the knowledge and experience to go beyond the minimum requirements and ensure that the electrical system is safe and reliable. Grounding is a critical aspect of electrical safety. It is essential to understand the principles of grounding and to follow the NEC requirements to ensure that electrical systems are properly grounded. Improper grounding can have serious consequences, including electrical shock, fire hazards, and equipment damage. Always consult with a qualified electrician when installing or modifying electrical systems. Relying solely on a Locknut and bushing combination for grounding is not a compliant practice. The NEC mandates specific listed methods to create a safe and effective grounding path. Therefore, it is essential to explore and implement the correct grounding methods to comply with electrical standards and protect against potential hazards.